Guys, welcome back to our video series of system modeling and simulation. We are going to continue with the stock and flow graph or the stock and flow diagram. These are the symbols we use in a stock and flow diagram. So we have a level. This is a level. The level is also called a stock. A stock. This is a rate. A rate is also called a flow. And here we have an auxiliary. We have an auxiliary. And then here we have the source. We have a constant. We have a flow arc. And then cause and effect arc. So let's try to understand one by one what this symbol means. Now, the two key symbols are the symbol of level and the key notions are in this diagram are level and then rates. Level, which are also called stock, they are called stock accumulation or state variable. So it is a quantity that accumulates over time and changes its value by accumulating or integrating rate. Change continuously over time even when the rates are changing discontinuously. So these are variables, whose level of accumulation change. We are going to see example. So this is how we represent it, is a rectangle. And then we have rates that are also called flow or activity or movement. So they change the values of level. So rates change the value of stock. So the rates change the value of stock, the values of stock, so if stock changes, it's because they are influenced by rate of flows. Now, what are auxiliaries? Auxiliary arise when the formulation of a level's influence on a rate involves one or more intermediate calculation, often useful in formulating complex equation used for ease of communication and clarity. So auxiliaries are are variable, used when it comes to formulate some intermediate calculations. We're going to have in a stock and flow diagram, we don't only have stocks and flows, but we also have auxiliaries. We also have constant. Constant are kind of auxiliaries not changing. Constant. Constant are auxiliaries not changing like this. Constant, this one. A constant is an auxiliary not changing. Auxiliaries change, but a constant is something, you understand? A constant is something which does not change. You understand it? So they are kind of auxiliaries that do not change. And sink is the source, a source and sink. They represent it like this: source and sink. Source means the starting, source represents system of level and rates outside the boundary of the model. The outside. Sink is where flows terminate, they are also outside the system. So the source and the sink represent, the boundary, of the system, where the system starts and where the system ends. So this is the source. Here also, if you want, you can put a sink, a source, and then here you can put a sink if you want. But what interests us here, are this rate and this stock. You see. Now, how do we get, in a previous video I told you that you get the stock and flow diagram from the causal diagram. So we know the causal. We know the causal diagram, we understand it. So the more you have birth, the more you have population. The more you have population, the more you have birth. So this is a reinforcing feedback loop, a reinforcing loop. Now we have this. How do we translate it? How do we translate it into stock and flow? Now we have to understand, when you have variable like this is a variable, this is a variable. Now you have to understand whether it is a stock or a flow. Now population is a stock because population accumulates. But the population accumulates because of birth. So birth is a flow, and then population is a stock. So it is why this is represented as a flow, and this one is a stock. And then we have a loop. This is, cause and effect arc, which is a loop. This loop. This one is represented by this flow arc. Now this loop coming back here is represented by this dash 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 dash, cause and effect arc. So we have this feedback loop. This is a feedback loop. And birth represents flow, because we say flow influence stock. The population is accumulating. The population is accumulating. You see, the population is accumulating. So it is a stock, and the population accumulates because of birth. You get that? So birth is a flow. Now here we have a source, and if you want here you can put a sink. Good. Now let's translate this. Here we have the source, here we have the sink. Now here children, here we have children, you have children maturity, and here we have adult. Birth, we said, so the more you have birth, the more you have children. So let's start with here. Let's start with these. So this is a causal graph. This is a causal graph which is translated into a stock and flow graph. So the more you have birth, the more you have children. The more you have children, the more you have children maturity. The more you have children maturity, the more you have adult. The more you have adult, the more you have birth. So this loop here, this loop here, and here is, here we have two feedback loop. This one, from birth to children, from children to children maturity, from children maturity to adult, and from adult to birth. So it is reinforcing, because we move from more to more to more to more. Now this one here is balancing, because we have, the more we have children, the more we have children maturity. The more we have children maturity, the less we have children. So it is Reinforcing. Now, how do you translate it? The first thing to do is to understand what is what is a stock and what is a flow. What is a stock and what is a flow. So both are flows because they influence, you know, the stock of children. The stock of children accumulates. The stock of children accumulates when we have birth. And when we have children here, they're influenced by their maturity. And this maturity influences adult. So we have adult because children are becoming mature. We have adult accumulating because children are becoming mature. So this is a flow. You get that? Good. And then we have this feedback loop. We have this feedback loop. And then here we have, you see, this feedback loop. And this feedback loop. You get that? So this is an example of causal graph which has been translated into stock and flow diagram. Now, you should understand that in a stock and flow diagram, everything is not stock or flow. Everything is not stock or flow. You can also have auxiliaries. And these auxiliaries can also be constant. You know, good. Now, we don't use dynamo. Dynamo is we don't use dynamo. For us, we are going to use any logic. So this math, is we're not going to talk about this math. These are different ways of representing. You can have a causal graph, you have flow graph, you can have the block graph, you can have equation. For us, we use these two, causal graph and flow chart. They're enough. So we don't need the blocks, and equation. So we don't need to bother ourselves with that, all that. Good. Now let's have an example here. This is an example of causal graph. We said everything is not everything is not stock and everything is not flow. The main variable are stock or flow, but the rest are auxiliaries. Like this one, you see, this one will be an auxiliary, this one will be an auxiliary, this one an auxiliary, this one an auxiliary, and this one an auxiliary. Construction will be a flow, demolition will be a flow, and industrial building will be a stock. You get that? So what do we get here? You see, that's it. Here we go. Here we go. You get that? So here we have only one stock. We have industrial building accumulating, but they accumulate because of construction. But they are also affected by demolition. If they demolish, they are going to get reduced. And the other variables are auxiliaries. All of them are auxiliaries. But these one are constant. Average, this one average, this one they are constant. But auxiliaries are also constant. Constant are also auxiliaries, only that they don't vary, so they're not variables. You see? So this causal graph here is transformed into a stock and flow. Everything is not stock or flow. We only have one stock. We have a stock of industrial building, which is influenced by construction, which is a rate, and demolition, which is another rate. All the rest are auxiliaries. Auxiliaries are, include some calculation or some constant affecting, the stock or the flows or affecting other auxiliaries. So briefly, uh, this is how we translate a causal graph into a stock and flow diagram. Now um, we are going to move. We are going to have a lab. We're going to have a lab, the lab 3. We are going to simulate the spread of a disease. You see, actually, we have a we have this disease called what? COVID. You know, we have this COVID, caused by the coronavirus. So you can simulate how it can. This is a very good project. You can simulate how it is spreading. In the population. So this is an example. To simulate how a disease spreads in the population using system dynamics. So this is going to be the lab, lab 3 that you are going to take. So but before you take it, there are diagrams, there are stock and flow diagrams you guys need to understand. So we are going to cover that in the next video. So we're going to try to understand the problem we are having here, and then you guys are going to simulate it. So see you in the next video. So I hope you have enjoyed this one. Bye bye. Thank you for watching.